In today's lesson, we will be taking monomials to a power. And that is really just a fancy way of saying we're going to take products to a power, which that's a fancy way of saying we're going to take some sort of multiplication, let's say 4 times x to the third, and we're going to raise that to a power. And then the other one is we're going to take quotients to a power, which that is a fancy way of saying we're going to take some sort of division or a fraction to a power. We're taking the whole thing to a power. We will first explore the idea of raising a product to a power. So for the first example, the product is 4 times x squared. And we're going to raise that whole thing to the power of 3. So what that means is that we have 3 of these, 3 4x squared. So if I write it all out, 4x squared times 4x squared times 4x squared. Now, how many 4's do we have? 1, 2, 3. So that's kind of like saying 4 to the third power, and then we have to look at our x's. How many x's do we have? Remember, each one of these are saying we have 2. So we have 2, 4, 6. So x to the power of 6. And then you can go one step further. What is 4 to the third power, or 4 times 4 times 4? It is 64, and we have x to the power of 6. Next we have the product 2 times p, and we're raising that to the power of 4. So that exponent 4 means that we have 4 of these, 4 of the 2p's. So 2p times 2p times 2p times 2p. So when we rewrite this, let's count. We've got 1, 2, 3, 4 2's. So that would be saying 2 to the 4th power. And then we have 1, 2, 3, 4 p's, which is p to the 4th power. And go one step further and actually evaluate 2 to the 4th power. So that is 16 p to the power of 4. Now we have the product xy squared, and we're raising that product to the power of 5. So we have to write xy squared 5 times. So xy squared times xy squared times xy squared times xy squared, and one more times xy squared. So now, count up all of our x's. Each one of these is just 1, so 1, 2, 3, 4, 5 would be x to the 5th power. And then if you count your y's, we've written it out 5 times, but each one represents 2. So 2, 4, 6, 8, and 10. So that is x to the 5th, y to the 10th. And that's as far as we can go. Alright, 2 more examples, and these ones are a little bit shorter. The first one, we have a negative 5x is our product, and we're going to raise it to the power of 2. So that just means we have negative 5x times negative 5x. And then, what is, let's see, negative 5 times negative 5 is a positive 25, and x times x is x squared. And our last example, this time negative on the outside, and then 5x on the inside, and you square it. What this is really saying is, you have a negative sign, and then inside you're going to do 5x times 5x. So that means your final answer is negative. 5 times 5 is 25, x times x is x squared. So there you go, raising a product to a power. Okay, let's look back at what we just did and see if we notice any sort of pattern. I want you to look at where you start and then where we ended right here. So it became 4 to the third power and then 4 to the sixth power, and if you notice, if you multiply your exponents, 2 times 3. Let's look at this one. It became x to the fifth power and then y, let's see, to the 10th, which is 2 times 5. So if you have a product, a times b, to the power of m, you can think of it as everything inside the parentheses have to be raised to that power. So it would be a to the power of m times b to the power of m. And what I like to call this, even though it's not the mathematically correct word for this situation, it's like you're distributing that exponent to everything inside. So let's do a very quick example that you don't need to write down using that idea. Let's say we have 2x squared to the power of 4. If we distribute the exponents, it would be 2 to the fourth power, and then it would be x squared to the fourth power, power of a power, we multiply exponents, x to the 8th. And then just evaluate, so that it would be 16x to the 8th. In this next property, we will raise a quotient to a power, in other words, a fraction to a power. So the first one, let's say we're just raising the simple fraction of 1/2 to the third power. That means we have 1/2 times 1/2 times 1/2. And you could think of that as, well, let's see, 1 times 1 times 1 is 1 to the third power, and 2 times 2 times 2 is 2 to the third power. But really, what does that equal? It would equal 1 over 8. Now let's look at one with variables. X squared over 3 is my fraction, and we're raising that to the power of 2. So that means I'm going to write my fraction twice. X squared over 3 times x squared over 3. So x squared times x squared would mean x to the fourth, and 3 times 3 is 3 squared, which equals x to the fourth over 9. Okay, let's make it a little bit more complicated. My fraction is 1 over 3x squared to the power of 4. So that means I have to write my fraction 4 times. 1 over 3x squared times 1 over 3x squared times 1 over 3x squared times 1 over 3x squared. So all of that, 1 times 1 times 1 times 1, is basically saying 1 to the power of 4. All over 3 times 3 times 3 times 3 is 3 to the power of 4. But my x's, I have it written 4 times, but each one is raised to the power of 2. So 2, 4, 6, 8, x to the power of 8. And if you evaluate this further, 1 to the fourth power is 1. 3 to the fourth power is 81. And then we have x to the power of 8. Alright, now negative 2 over 3 to the power of, let's do 4 again. So no variables. Let's see, negative 2 times negative 2 times negative 2 times negative 2. You could think of all of those going in one big numerator even. And then 3 times 3 times 3 times 3. Students actually like this way, just writing one big numerator and one big denominator. So negative 2 times itself 4 times is a positive 16. And 3 times itself 4 times is 81. And here's our last example of this property. 3t squared over 5, and then we're going to square it. So just like that last one, we can write one big numerator and one big denominator. In my numerator, we have 3t squared times itself 3t squared. And then denominator 5 times 5 equals, if we have two 3's, that is 3 squared. And then we have t to the 4th power over 2 5's would be 5 squared. And go further, that is 9 t to the 4th power over 25. And there we go. So let's once again look back at what we've done and see what we notice. So 1/2 to the 3rd power became 1 to the 3rd, 2 to the 3rd. In this one, 1 over 3x squared to the 4th, we raised everything to the 4th power, 1 to the 4th, 3 to the 4th, and then it became x to the 8th, because we multiplied those exponents. And this last one, it became 3 squared t to the 4th, 5 squared. We had to raise everything to the power of 2. So here's another property. If we have a quotient, a over b, so a fraction, and we raise it to a power of m, we have to raise everything inside that quotient to the power of m. So it becomes a to the power of m over b to the power of m. So once again, I call this, we're distributing exponents, even though technically you can't call it the distributive property. So let's do an example. Don't write this down. Let's just think about it. If we have 2 over 3x squared, and we're going to raise that to the power of 3, we have to take this outside exponent and raise it to everything on the inside. So it becomes 2 to the 3rd power over 3 to the 3rd power and then also x to the power of 6. So this really means 8 over 27x to the power of 6. So there's our full lesson on raising products to a power and quotients to a power. It gets pretty complicated, so students often like to write it all out. Even though it's a lot of work, it helps them get the right answer. So good luck.